Oumuamua, this strange object that was discovered 2017, don't quite match what you expected, and you're trying to find an explanation. It moved.
The quiet arrival of a messenger. In July of 2025, the high desert of Chile was cold and still when NASA's Atlas Survey telescope turned its gaze upward for another night of routine scanning. The system, designed to hunt for potentially hazardous asteroids that might cross Earth's path, swept across vast portions of the southern sky. 4 hours. Its automated detectors caught countless points of light, stars, galaxies, and the slow-moving dots of asteroids within our own solar system. But one faint point stood out. It shifted slightly against the background stars, just enough to be logged, marked, and stored for later review. At first, there was no sense of significance. Astronomers are used to finding such things, small icy bodies wandering through the solar system, each leaving behind a faint smear of activity as sunlight warms their frozen surfaces. But as the days passed, the data began to tell a stranger story. The object, which would soon be catalogued as 3I our Atlas, was not looping around the sun the way comets or asteroids do. Instead, its orbit was hyperbolic, a stretched path that would carry it past the sun only once before sending it back into the blackness of interstellar space forever. That single fact changed everything. 3I our Atlas was not a child of our solar system at all. It was a traveler from another star, only the third confirmed interstellar object in history, following the enigmatic Oumuamua in 2017 and the comet-like Borisov in 2019. Unlike those earlier visitors, however, this one had been spotted early, nearly 4 months before it would reach its closest approach to the sun. For astronomers, that was a priceless gift. It meant they could plan, coordinate, and prepare to watch an interstellar object from start to finish. Where Oumuamua had slipped past almost unnoticed, and Borisov had burned brightly but briefly, 3I our Atlas offered something unprecedented: time. A visitor unlike any other. The first images of 3I our Atlas showed a faint coma, a glowing cloud of gas and dust surrounding what appeared to be an icy nucleus. This immediately distinguished it from Oumuamua, which had baffled astronomers by showing no signs of outgassing at all, and instead behaving more like a strange, elongated rock. But 3I Atlas also seemed dimmer and less active than Borisov, which had flared dramatically and displayed a bright, obvious tail. Estimates suggested that 3I our Atlas might be up to 20 kilometers wide, though its hazy glow made this difficult to confirm. Its true size could be smaller, hidden beneath the blurred light of escaping gases. More striking than its appearance, however, was its velocity. Moving at nearly 60 kilometers per second, or over 216,000 kilometers per hour, it was traveling at twice the speed of Earth's orbit around the sun. At that pace, its entire passage through the solar system would last only a few months, a brief visit before it slipped forever into the endless gulf of interstellar space. Its perihelion, the closest point to the sun, was calculated to occur between October 29th and 30th, 2025. Around that time, astronomers expected it to be at its brightest, releasing the greatest amounts of gas and dust as the sun's heat worked upon it. For comet scientists, perihelion is the moment of truth, the time when these frozen wanderers reveal their innermost secrets, their compositions laid bare in the light. Spectral analysis promised to be the most powerful tool. By splitting the object's light into its component wavelengths, astronomers could detect the chemical fingerprints of its gases, water vapor, carbon-based molecules, or even exotic compounds unfamiliar to our solar system. Every emission line, every spectral signature, could tell the story of where 3I our Atlas was born, what star system it once belonged to, and how it came to be cast adrift. Standing in a line of ghosts. To understand the significance of 3I our Atlas, one must look back at its predecessors. The first, Oumuamua, stunned the world in 2017. It appeared as a long, narrow object, unlike any asteroid or comet ever seen. Stranger still, as it sped away from the sun, it experienced a tiny but measurable acceleration, something that could not be explained by gravity alone. Some scientists suggested it might be due to outgassing, but no gas or dust was ever detected. The mystery deepened when Avi Loeb, a Harvard astrophysicist, publicly argued that it might even be an artificial object, perhaps a probe or fragment of alien technology. Though the majority of the scientific community disagreed, the idea captured the imagination of the public and sparked debates that continue to this day. The second, Borisov, discovered in 2019, was far less mysterious but no less important. It looked and behaved much like a typical comet, with a bright coma and tail, and chemical signatures that matched those of icy bodies in our own solar system. For scientists, it was a reassuring confirmation. Other star systems produce comets just as we do, and fragments of them can and do wander into our neighborhood. Now came 3I, our Atlas, falling somewhere between the two. Like Borisov, it showed comet-like activity, but more subdued. Unlike Oumuamua, it did not defy explanation, but nor did it blaze dramatically across the sky. In its modest, steady way, it offered something else, an observation window long enough to study it thoroughly. For astronomers, that fact alone made it perhaps the most scientifically valuable of all. The technology that made it possible. For most of history, humanity would never have known 3I, our Atlas existed. Interstellar wanderers surely passed through the solar system countless times, but without modern tools, they would have been invisible. In the 20th century, astronomers relied on painstaking manual observation and photographic plates, covering only narrow slices of the sky. Small, fast-moving objects were almost impossible to spot. Even in the early 21st century, with improved telescopes, sky coverage was limited, and data analysis was slow. The discovery of Oumuamua in 2017 and Borisov in 2019 were turning points. Both were found by modern survey programs, but in each case, the detection came late, after the object had already made its closest pass. The 2020s brought a revolution. Automated surveys like Atlas, Pan-STARRS, and the soon-to-be operational Vera Rubin Observatory began scanning the skies every clear night, covering huge portions of the heavens. With the aid of machine learning algorithms, these surveys could detect even faint points of light shifting slightly between images, flagging them for follow-up. Suddenly, the odds of catching fast-moving interstellar travelers improved dramatically. The discovery of 3I, our Atlas was no accident. It was the direct result of this new era of cosmic surveillance, a demonstration that humanity had finally become vigilant enough to spot visitors before they slipped away. The challenge of a mission. With early detection came an inevitable question. Could we send a spacecraft to meet it? The idea is tantalizing. Imagine intercepting an object born around another star, studying its surface up close, perhaps even collecting samples to bring back to Earth. It would be the ultimate message in a bottle from across the galaxy. But the reality is daunting. At 60 kilometers per second, 3I, our Atlas is moving far faster than any human spacecraft has ever traveled. To catch it, a mission would need to be planned years in advance, with complex gravity assist from planets or propulsion systems that do not yet exist. The window of time between discovery and departure is far too short to build, test, and launch a new mission from scratch. Some scientists argue that the solution is to build a ready-to-launch interstellar response probe, a spacecraft waiting in storage, equipped with modular instruments, ready to be launched at a moment's notice. It would be expensive, logistically complex, and politically difficult to justify, but the payoff could be enormous. Without such preparation, each interstellar visitor will remain a fleeting opportunity, observed only from afar. For 3I, our Atlas, the conclusion is clear. There will be no spacecraft. It will be studied remotely, through telescopes on Earth and in orbit, captured in data but never touched. And yet, the idea lingers. Next time, perhaps, humanity will be ready. A new perspective on the cosmos. The discovery of 3I, our Atlas has broader implications than its icy coma or chemical fingerprints. It signals a profound shift in how we see the universe. Before 2017, no interstellar object had ever been confirmed. Many scientists assumed they were vanishingly rare, perhaps appearing once in centuries. Now, in less than a decade, 3 have been found. The conclusion is inescapable. Such visitors are not rare at all. They are part of a steady rain of debris from other star systems, passing unnoticed for millennia until now. This changes more than astronomy. It changes perspective. These objects are physical proof that the solar system is not isolated. We live in an ocean of stars, and material drifts between them, carrying stories of alien suns, distant worlds, and the violent processes that eject them into the void. Each one is a message, a fragment of another place, arriving uninvited but invaluable. For the public, the discoveries can inspire awe. It is one thing to gaze at distant stars and know that exoplanets orbit them. It is another to realize that fragments of those systems have flown past our very sun, visible through our telescopes, sometimes even detectable to backyard astronomers with modest equipment. The galaxy, suddenly, feels smaller, more connected, more alive with exchange. Toward the future. As October 2025 approaches, astronomers prepare their instruments. Every major observatory will be watching 3-Eye Atlas. Radio telescopes will listen for signals in its tail of dust. Optical telescopes will track its brightness and coma. Space-based observatories will peer into its spectrum, teasing out chemical signatures. The global community, coordinated as never before, will build a complete picture of this interstellar traveler. And when it finally fades in December, heading outward into the cold dark, it will leave behind more than data. It will leave a legacy of preparedness, a sense of possibility, and the knowledge that such encounters are no longer once-in-a-lifetime rarities. They are the beginning of a new chapter. In the decades ahead, with better surveys, with faster missions, perhaps even with spacecraft waiting in silent readiness, humanity will do more than watch these messengers pass. We will chase them, meet them, and learn from them. In time, we may even bring a fragment of another star system home. For now, 3-Eye Atlas races onward, indifferent to our curiosity, a wanderer flung across the galaxy, carrying the secrets of a distant sun. And here, on this small planet orbiting an ordinary star, we watch, we wonder, and we wait, aware at last that the universe does not come to us only in the light of distant stars, but in the form of travelers that pass directly through our sky, reminding us that we are part of a larger, restless cosmos.